Hello everyone, welcome to Module 6.3, Predicting Chemical Reactions. Okay, so the learning objective for this section is to predict the products of a double displacement reaction. And then I'm saying we will discuss solubility later. This section is going to be very different than some of the others we've looked at, and that we are actually skipping a lot of the material from the textbook. We will be coming back to that material when we get to chapter 14. And the reason we're doing this is there's a lot of information here that I think is better understood in the context of understanding what a solution is, which is what chapter 14 is about. And I want to focus more on understanding what reactions are and what reactions can do. So I want to approach this a little bit differently than your textbook does. So just be aware as we go through this, there's a lot of information in your textbook we are not getting into great detail on right now. However, we will come back and cover that in more detail later in the course. Okay, we had already discussed classifying chemical reactions. And we're going to focus on one particular type of reaction for this, which is the double displacement reaction. These, again, were perhaps the most complicated of these reaction types. And it's one type of reaction that, as we'll see, we want to be able to start with, given what we know, what we start with, predict what we end up with. We should actually be able to do that for the single displacement as well. But we're focusing it on it here because it ties into some of the ideas we saw in Module 4. Okay, there's a lot of information in your book, and what I'm going to do is I'm going to show you which of these several steps we can focus on. And there's basically 3 steps. We can leave out half of the steps here. And we can still do what we need to do. And again, this is a little bit tricky because your book doesn't really disentangle them this way, but I think it's possible to do that and still understand how this works. So the first step is to write the formulas of the 2 compounds being mixed as reactants in a chemical equation. You may be given the question such that it is already shown in this way. But you might be given the question in terms of their names, and you would need to be able to take their names and write their formulas, because that's something we talked about already in terms of that's something I would expect you to be able to do. The second step, combine the cation from one reactant with the anion from the other. So this is essentially what we're doing. We're switching places. And one thing I should mention here, for all of these, for every single double replacement reaction, we are dealing with ionic compounds. Okay, so we will always have ionic compounds. We will always have anions and cations, and the anions and cations switching places. So as you're doing this, this is really the key step in this whole process, is that you write the correct formulas for the new ionic compounds. These these new formulas need to be charge neutral. Okay, so, and we'll go through and look at an example of this, but this is the key to the whole process. We can skip over all of these other steps. We'll come back to them later. And then the final step is to balance the equation. So you've already shown what you form and then balance the equation. At this step, you are adjusting coefficients, not subscripts. At this step, you are deciding what the new compounds are going to be. So you need to write the subscripts that make them correctly balanced. So here you figure out the subscripts, here you figure out the coefficients. And if you can do that, you should be able to do this process. Okay, so I'm going to look at a couple examples. These are all going to be from your textbook. And I'm going to look at these a little bit differently, though, because we're going to cut out the middle steps that we're going to come back to later. So the question says, write an equation for the precipitation reaction that occurs, if any, when solutions of sodium carbonate and copper 2 chloride are mixed. to start with, I want to kind of specify something. We're not going to care too much about the fact that it is a precipitation reaction. As we'll see later, all of these double replacement reactions are precipitation reactions. But we're not going to worry too much about what the precipitate is. So that's part of what we're skipping over. What we want to focus on is, are we correctly balancing the new compounds in terms of their charges and the overall equation in terms of all of the atoms that take place in that equation. Okay, so first step is writing the formulas. So again, this is going back to basically to Module 4. So we look at sodium carbonate and we write the formula for that. We look at copper 2 chloride and we write the formula for that. So I would go ahead and pause your video, make sure you're able to do those, and then once you've done those, just check if you're on the right track. Okay, so these are the formulas. So Na2Cl3 for sodium carbonate, and then CuCl2 for copper 2 chloride. In terms of these formulas, remember that you have a -1 charge on sodium plus +1 charge on sodium, -2 on carbonate, so you need 2 sodiums for that to balance. And then over here you've got the 2 is telling us we have a +2 for copper, and then you need 2 of these chlorides at a -1 for that to balance. So that's something you should know from an earlier module, from Module 4. Okay, second step, we think of all of the possible compounds that could form if we were to rearrange these. And for now, we'll just say, okay, maybe this cation goes with this anion, so sodium and chloride will go together, copper and carbonate will go together. Now, when we do this, so we're switching places, and when we switch places, we need to rebalance the charges in the new compound. So we don't look at the subscripts that you start with, we look at the subscripts such that the charges balance. Again, try to do this on your own and then come back and see what we end up with. Okay, so we're showing the switching places here, and then these are what we get when we switch places. Okay, so I want to highlight a couple of things here. Notice we did not do anything with these subscripts. These subscripts are based on the charge balancing for the overall compound, as we did when we came up with these formulas earlier. However, we did include the subscript on this thing. And this is something that's often confusing to people, and I want to clarify why this is. Carbonate is one thing. Okay, so if you look up carbonate, you would see this formula. This is carbonate, CO subscript 3. So we have to include that subscript 3. That's part of what it is. These subscripts on sodium and chloride are not part of what they are. They're just saying how many we have in order for them to balance out. So when we switch places, we have sodium +1, chloride -1, so we have 1 and 1. So we have, they just balance out as a 1-to-1 ratio. And copper +2, carbonate -2, they also balance out in a 1-to-1 ratio. So these are the formulas of our products. Again, we did this based on the charges balancing. Okay, we're skipping to number 6. We don't care what the insoluble product is. We're not going to care about that part of it. We just want to balance the equation. So let's go ahead and balance this equation. And to make this balance, we have 2 sodiums, 2 chlorides. So we put a 2 in front of the sodium chloride. The others, so we have 1 of these, 1 of these. So these are all balanced already. So we don't have to do anything more there. You might notice we've identified solid and aqueous over here. Not important that you understand how to do that right now, so that's not the issue. The issue is, can you balance the overall equation, and can you decide what the products are going to be? Okay, let's look at another example. So I'll go ahead and read through this. Write an equation for the precipitation reaction, if any, that occurs when lead 2 acetate and sodium sulfate are mixed. If no reaction occurs, write no reaction. Okay, we're not going to worry about whether or not the reaction occurs. We're going to assume that it does. We're not going to worry about what the precipitate is. We just want to look at, First of all, can we correctly decide what the formulas are for these compounds? And then secondly, when we switch places, can we get the correct formulas for the new compounds that form? And then finally, can we balance the overall reaction? So go ahead and pause it, see if you can decide the formula for lead-2 acetate and for sodium sulfate. Okay, so here are the formulas. So lead, we have a positive 2 charge. Acetate has a -1 charge. This is the formula for acetate. Has a -1 charge, so we need 2 of them. Notice that we put parentheses around the whole formula of acetate, and then the subscript goes outside of that. For sulfate, we have a -2, sodium a +1, so again we need 2 sodiums to go with the 1 sulfate. We're next going to see what we get when we switch places. Now would be a good time to pause and see if you can do that, and then I'll show you what we get. Okay, so here's what we get when we switch places. So we have lead go with sulfate, sodium go with acetate. Again, each one we break into exactly two parts, the cation and the anion. This one is probably fairly straightforward to see where we break that apart because of the parentheses here. This one we have 3 things, and so we know that the sulfate is one thing, the sodium is another. So we break it into 2 parts, and then we bring those together. So again, this 2 on the sodium is not part of the sodium, that's just for the charge balance. So we take the sodium with the acetate, and again, we're just taking what's inside the parentheses, so we get sodium acetate. And then the lead and the sulfate will go together. For the sulfate, we do include that 4 subscript because that is part of the sulfate. So we have a +2 and a -2, so those will balance out. So then these would be our products over here. Go ahead, take a minute, see if you can balance that equation, and then I'll come back and finish this out. Okay, so here's the balanced equation. We have lead sulfate and sodium acetate as our products. We have just 1 lead, just 1 sulfate, so that one's fine. 2 acetates and 2 sodium, so we put a coefficient of 2 in front of the sodium acetate. Okay, again, so the steps we care about here, from the names, identify the formulas of the reactants, correctly switch places for the products and get the correctly balanced formulas for what we end up with, and then balance the equation by adding coefficients. Okay, you'll get some additional practice for this on worksheet 6.3. If you have questions about it, you can share those on the discussion board and then proceed on to 6.4 when you are ready.